Okay, in the second exercise here, this is a really, I really think this one is interesting, and it's worth moving forward with some additional news, in my opinion, additional analysis after this, which is worth a future talk, a future exercise, in my opinion. So what is machine learning? Machine learning is the process of using mathematical methods of data to help a computer learn without direct instruction. It is considered a subset of artificial intelligence, and machine learning uses algorithms to identify patterns within data. Okay, understand patterns within data. And those patterns are then used to create a data model that can make predictions. It can forecast information, forecast future events. With increased data and experience, the results of machine learning are more accurate, much like how we humans improve with more practice. Isn't that pretty neat? So how is machine learning used? Well, if you've ever seen a chat bot or spell check, which is known as predictive text, language translation applications such as Google Translate, if you watch Amazon Prime, Hulu, or Netflix, if you notice, after a while, it'll suggest shows to you, as well as if you're looking at something like Instagram or Twitter, there'll be posts that'll show up in your social media feed that pertains to what you are interested in looking at that time or at any time. In addition, machine language is now being utilized in autonomous vehicles and machines or robots that can diagnose medical conditions on what it sees, right? So we have vehicles that operate by themselves. They could be cars, they could be trucks, they could be drones, okay? They can be machines, these tools that could look at our bodies and based on our medical base and create a diagnosis based on what it sees, okay? It's a good application. Machine language is a good application for adapting to scenarios where the data is constantly changing, where tasks are shifting, where you have changing environments. We call that a dynamic environment, where you have sales or purchases, those volumes which are constantly changing, okay? It's impossible to code or program all kinds of constant variations. But with machine language, we can use these mathematical models to read those live dynamic events. And the algorithm can make determinations or predictions or what we also call inferences about those metrics, which sometimes we call those weights and biases. So it helps us understand what is contributing to the information that we're observing. It's very, very powerful. So how will it be used in this lecture? Well, for the purposes of producing analytics and determinations on the Miami housing data. And our data set is from 2016. It's an older data set, but even that by itself is going to open up some interesting components to us. This is a much more difficult exercise. There are several more libraries that are incorporated into Python. We have Folium, and Folium builds on the data wrangling strengths of the Python ecosystem. And it's mapping strings of something called Leaflet JavaScript library. So it allows you to manipulate your data in Python and then visualize the data in a Leaflet map. The next one is NumPy or NumPy. NumPy is a very powerful library that adds the computational power of languages like C and Fortran. Fortran is a very powerful language that's 40, 50 years old. And it's still with us today, but it's very mathematical and complicated. But when it's used, NumPy is utilizing these languages in Python, it'll be much easier for you to learn and use. And with its power comes simplicity. And the solution in NumPy is often clear and elegant. That's the way some people like to call it. The next one is pandas, which we're already familiar with. Next one after that is called Seaborn. And Seaborn is a statistical data visualization language. It provides a high-level interface, a high-level interface for drawing attractive statistical graphics. And the last one is TensorFlow. TensorFlow, which is a very, very powerful language, very popular today. Which, let's see here, make sure I get the right thing here. TensorFlow, which is a set of software libraries for our machine learning programs, which focuses on training and inferences of deep neural networks. Okay, it's a very, very powerful set of libraries that basically allow it to learn from observing data. It's very, very interesting. So we'll see how these work and play out today. Oops, did I miss something? So how will it be used? Oops, oh my goodness, what did I just do? So how will it be used in this lecture? We're going to utilize this. We're going to utilize it to gotta get my data sets up. We're going to be using it to evaluate the real estate database for patterns and statistically evaluating and analyzing the data. And with that, it's going to generate some insights for us to understand the Miami real estate marketplace. What I want to see. So once again, we're going to start this exercise. We're going to review the intro again and take a look at the data. We're going to read the code and review each step and discuss the output. What I also have, I'm going to have on hand is, I'm going to always have on hand a copy of the data description because the reason why is because it's a very complicated data set. It's a very complicated data set, and we're going to be talking about those data. So I'm going to just have this on the side while we're going through the data set here. It contains almost 14,000 single-family homes that were sold in Miami from the year 2016. The data set contains the following columns: parcel number, sales price, land area in square feet, total floor area in square feet, value of special features, if there's swimming pools, etc. The distance to the nearest rail line, which is an indicator of noise. Ocean distance, how close is it to the ocean in feet? Distance to the nearest body of water in feet. Distance to the Miami Central Business District in feet. Distance to the nearest sub-center in feet. Distance to the nearest highway, another indicator of noise. The age of the building, of the structure. A dummy variable for airplane noise exceeding an acceptable level. Structure quality, the quality of the building. You know, is it a highly well-built structure or not? The month sold, which is in January. Okay, and last but not least, latitude, longitude. This is a mouthful, folks. Importing the libraries, once again, we went through the description. It's a lot of data there. It'll take a minute for these to import. Okay, It's done. Now we're going to read the file. I'm going to read the file, which is called Miami Housing Dataset. This is it here. Okay, it's a CSV file. And what is a CSV file again? I'll wait for the comments. It's a comma delimited file. Very good. And we're then going to print the file. We print it here. So what it shows us the first 5 records, and it shows us the last 5 records. There are almost 14,000 rows, and there's 17 columns. Okay, this is a pretty substantial data set. Lots of variables to work on. Next step is to explore the data set. What is it? These are the data types. Float and integers. Remember, floats are data with decimal places. Okay, decimal places. Integers are data without their whole numbers. Okay, they're whole numbers. They don't have integers. Okay. And let's see what the description of the data. So these are, when we say describe here, describe is basically to describe, to provide the descriptive statistics, And what do we mean by descriptive statistics? How many, the average, the standard deviation, the minimum value, that's like the lowest value, the 25 percentile in the data set, the median percentile in the data set, I forgot this, but the 70th percentile is like the 3rd quintile of the data set, and the largest value in the data set. So that becomes important when you're probably looking at the age of a house. The oldest house sold during that time was 96 years old. And the earliest value is 0, meaning new construction, brand new. 25% of the homes that was sold were around 14 years old. Half of the homes were about 26 years old. So that gives you an idea of, at least for Miami, half of the homes, okay, half of the homes in Miami are 26 years old. 75% or more of the homes, this 3rd quartile, is 46 years old. So in Miami, the majority of the homes in Miami are 26 years old and older. The majority of the homes in Miami. That means Miami-Dade has a lot of old homes. That's what that means. Because if you look at some counties, some other municipalities in the United States that are, say, newer cities, they're going to lean more in this direction. And we'll see that in other exercises if we get that far. Next step, we're creating a figure here. No, I didn't push it. There we go. Box plot. Box plot. And to understand box plots, I actually have something a little special for us. I produced. And this here is how to read a box plot. So really, really quick, how do we read this box plot? Okay, this is the box plot here. Okay, and this is the call for that figure, pulling up the file. So it's looking at the entire data set, and some configuration. Okay, we plot it here only on sales prices. Okay, sales prices. And let's just look at this here. So this here, explaining the box plot, This is that end line here, which that end line is somewhere, I'm going to say it's somewhere here, which illustrates that there's a large number of properties that are way off the scale, way off the average, way off the third quartile, which is here. Okay, this line here, this line in here in the middle is the median. This line here is the first quartile, and this is the minimum value. So none of the homes were sold for free. Okay, nothing was given away. However, this here would be considered $500,000. This here is considered $1 million and beyond. Okay, I hope that helped a little bit. Next plot. Oh, this is an interesting plot. This is a multi plot here. We have a histogram on the y-axis and a histogram, histogram on the x-axis and a histogram on the y-axis. What that shows us is the distribution of data. The distribution of data here, let me just bring this down just a tad bit, based on square foot and sale price. Now, once again, when we say square foot, we're talking about land area, the land area of the property, not the size of the house, but just looking at the land area and the sale price. That's what's going on here. So you can see that the overwhelming majority of the property that is sold are under 10,000 square feet. But Miami, being an older community, has a lot, and I could tell you this, a lot of the homes sit on pretty large pieces of property that run off into this here. So you'll have a small home on a large piece of land. That is common in Miami, in many parts of Miami. And that's what you're seeing here. And that's why you have, and it would be nice if we had perhaps regions or something like that plotted on here, because it would show us what parts of Miami do those exist in, which would be very good, interesting to see as well. So for a realtor, to understand their marketplace is very important to see this. And for someone who's buying, they might be interested to look at property with a lot of land around the house. Okay, and for someone who is interested in buying the property for the purposes of building, knocking that property down and building on top of it, also very, very important. In Miami, we have a lot of infill development. Though it's very important for people to buy a home, regardless of the size of that home, how small it is, because it's typically an old home and may only have 2 bedrooms. And you can knock it down and build a 5-bedroom property with plenty of space. So you can see the distribution of that. That helps. Okay. Going to the next one. This one is dispersion between variables. This is a cluster. Okay. Once again, sale price of property, which we have many properties in the millions, as you can see, that were sold. But the overwhelming bulk of properties are somewhere between a little less than $1 million down to a little bit over 100,000, around that time, around that space. And you can kind of see that there's this funny little area right here. These are new homes. Okay, because when a new home in Florida is anything under 10 years old. And in that new home, you have this range here, and I guarantee you, these are townhomes. These are townhomes that are relatively new construction because there's not a whole lot of space. So they'll build 2 townhomes on a space of 1 home, on one old property. One old single home will get rezoned and they'll put a multi-dwelling on there. It's townhomes or multi-dwellings in general. Okay, but then of course you have a lot of new construction. Okay, there's a lot of new construction, and those homes are very, very expensive, going beyond the $500,000 price all the way up into multiple millions. However, let's look at structure quality, and sale price. These are older homes resold, very poor structure. And the reason why there's gaps is because the structure quality is integers. They're not float values. So it's 1, 2, 3, 4, 5. That's why it's this way. And once again, you have to understand your data for that to take place. And we don't have any null data. Okay, there aren't any gaps. Okay, next one. Oh, this is a good one. Showing that we don't have any null data here. It's okay. It's just verifying this. Next one. This here is a histogram showing data explanation. Dummy variable. So this is a dummy variable for airplane noise exceeding an acceptable level. That's what this is. And it's 0. But there's a small number. There's a small number right here of 208 that are within a airport. That are within proximity of an airport, and they're that were sold near an airport's flight path where the plane is so low because it's so close to the airport. You're going to hear that plane fly over your house every time that plane lands. Okay, no fun. But in a market like Miami, people are going to live there. Next one. This is a histogram of the structure quality, once again, of what we were looking at here. But this is a histogram of the this is a histogram of the structure quality. Okay, showing you that these are poor qualities. A lot of over 4,000 poor quality homes are sold. Over 100 poor quality homes are sold. Almost 200. Remember, these more than likely knocked down, slated for reconstruction or redevelopment. Very little redevelopment, or just some home improvement, but lots of home improvement, I guarantee you, on this. Next one. And I apologize for this. I would have used a better color scheme for this because this is a little bit more. This color scheme gets a little complicated. But there's a histogram on homes sold, what month it was sold in that year. So notice it's low in the first couple of months, but then it picks up. And my question is, why do you think it picks up from here to here? What could be the reason? What could be the reason? I'll wait for an answer in the chat. And I could tell you more than likely it's because people got their tax return, got a real nice hefty tax return, and they use that to help put down on a house. Okay, and it carries through the year. So that carries up to this because it'll take about 1 to 2 months to close on a house based on the type of mortgage that's used. If it's a conventional, you've got a month for Florida. If it is a VA loan or any type like that, it'll take 2 months. Easily can take 2 months. Typically it's 45 days to 2 months. It can speed up. In Florida, you can sell a house in 2 weeks. You can close in 2 weeks in Florida. That's correct, that fast. Okay, next one. Yeah, this is a mess. So, and this histogram just shows the age of the home against the number sold. This new construction, once again, new construction, lots of townhomes, folks. And not that many new homes sold because people have their new homes and they're keeping their new homes. But then you have people who have owned their home for some time and they are so excited because they bought during the prior, let's say prior 10, 15 years we're talking prior to 2008 or around that time. I'm sorry, around 2008 time when the price of homes were super low. So these folks are selling out, and there's lots of equity coming out of them homes. They're taking their equity with them. That's what we see there. These are very, very old homes that were sold. Next one. Once again, histogram, looking at sale price. Is a big file. Okay, and this lovely histogram, this is a very nice one actually, a bit colorful, but what we have is sale price. Remember, once again, folks, this is 2016. This is not present day or past 2 years where prices were even more price. Put it this way, this is 2016, this hump. If we looked at a hump in 2021, this hump would be shifted over here. This whole thing would be over here because the bulk of homes are selling between the high 400,000 into the mid up into 800,000 for Miami. That's right. That's a huge amount of equity. I hope you're enjoying this. Please give me some feedback in the chat room if you're enjoying this. Oh, this is a very sophisticated one. So this is looking at the Seaborn. This is definitely a Seaborn library used here. And this is plotting the file looking at correlations. So it's taking the data and looking at each specific attribute as to how it correlates with the other data set. And I apologize, I can't put the whole thing here, but I'll try to keep it like this. You can't see the bottom, so I got to bring the bottom here. So we're cutting off that long, but what this means, correlation, relationship. How does one attribute, such as latitude, relate to latitude? Well, if you took latitude and divided it by latitude, what would you get? You'd get 1. So the correlation is 100%. The correlation is 1. Our Earth is not perfectly a sphere, so our projection of latitude versus longitude are not 1-to-1. They are about, they're 0.72 to 72 related. This is also understandable. This is a high degree of, this is still considered a relatively high degree of correlation. Not, in my opinion, a super high degree of correlation, but they are very well correlated. That's what that means. This means between parcel number and, I'm going to have to come down now, parcel number and latitude, none. Very little, none. Okay. If we get to utilizing this bar here, very important, very light color, high degree of correlation, dark color, negatively correlated, reddish, no correlation. So if we stick to these here, center, district, rail or highway, you can see on these what degrees of correlation. So if you look at this component right here, there's some degree of correlation between these variables and these variables. Okay, there's some degree of correlation. They're negatively correlated between this and age. So let's take a look at a feature. Let's look at this one here, Central District. Central District and sales price. Central District and sales price. So this is Central District and sales price right here. Negatively correlated. So, and it's not a whole lot of correlation. And it shouldn't be, because in Miami, you could be in certain areas of Miami far from the city, and the price of the home is very high. So that's what throws it off. Let's take a look at another one. Highway distance. Let's look at highway distance and price. Highway distance and sales price. Still basically the same as the last one. Not a lot of correlation. Is highway distance highly correlated with anything? 0.4, there's some correlation, and that one is some correlation with water. Highway and water. I'd have to look at that on a map. Doesn't mean a whole lot. In my opinion, it could mean anything. Let's find something else. Let's take a look at subcenter. And I don't know what they're calling subcenter. The data set does not give enough descriptive terminology, but subcenter to me, could mean another business district. Okay. And they're saying that if it's next to the city center and some other subcenter, it's highly correlated. Okay. But how about city center and price? City center and price. Negatively correlated. And that's because some of the city back, and once again, we're talking 2016, if we were looking at a data set in past 2 years, I guarantee you there's going to be a high degree of correlation with city center, because everything within the city center of Miami, all those properties are $1 million or more, regardless what they look like, even if it's not even livable. So I think you get an understanding of how this figure works. It's a very powerful one. You could spend a week talking about that. Let's go to the next one. Oh, this is nice. So in this one here, we're looking at the data frame for the entire data set, and looking at latitude, this must be count. Yeah. Tells you what areas that things are being sold in. I'm looking at parcel numbers, longitude, certain areas, sales price, majority of the homes sold around there. So people are taking profit based on those homes, improving value based on what they started out at the end of the last housing crash. And little area. Let's see, have any comments in there in the chat that look at anything specific here? Well, you could see the relationships of property and living area. These are specific features like a swimming pool and the value that it has. And that's is having some contribution, not a whole lot. Some people made a few major improvements to their property, which added some value to the property. Okay. Let's move on. Oh. It's a warning. And this is distribution of frequencies. This is in Portuguese. This is distribution of frequency, which would be property price log. Distribution of frequency. So this is a frequency distribution. Okay. It's frequency distribution for let's run it again. Frequency distribution for the property price. Once again, this is going to relate to what we've seen once again, but also take into consideration is 2016. If we were looking at 2020, 2021, this would be to the right. It'd be over here. Heat map where most properties are found. Oh, it is a good one. So most of the properties that were sold everywhere. This is the airport. And there's some industrial areas. A lot of industrial areas here. These are communities in Miami. Not too many were sold on South Beach in 2016. So somebody was holding. Quite a few were sold in Key Biscayne, but not everything. Major saturation of sales. And we can zoom in and look at more the individual sales. Huge cluster concentrations. So you can see there are concentrations in certain areas. And this is east of US 1. Okay, so east of US 1, these are the old communities of Coconut Grove. Major concentrations of sales. Whereas on this side, you don't have that. Okay, here, once again, another area of like the Grove, very beautiful parts of Miami. Major concentrations here. Nobody sold on this island. A lot of people didn't sell on the roads either. Okay, but we've got quite a bit over here in this area. The very, very beautiful part of Miami, the homes in this area. Yeah, I wanted to see Little Havana. Not a whole lot of sales in Little Havana either. I would have, you could have expected more, but no, not back in 2016. Many sales over here. This is the Miami Wynwood area. You see that? All that sales. However, up here, look at this cluster. Half or more of the property sold. North Bay Village. Many properties sold in North Bay Village. North Miami. Opelika. Golden Glades. Miami Gardens, where the Formula One is now. Okay. Last figure. Once again, using Fulcrum, lat long. It's taking a bit for this one. It's a big file. Here you go. There's a nice map here. So you can look at the individual sales. See? That's 920,000, folks. Okay. Any particular place you want me to look? Let's look at, this is the design district. Not a lot of sales. 475. I can tell right now that would be 975 today, if not more. Especially as you go further down here. All right. Oh, there's actually another one. There's more going on. Okay, we're going to keep going because there's a lot more. There's still a little bit more to do. So let's not waste time. So here we have another cluster and map, looking at features. It's a cluster map, looking at prices and age. Similar map as we've seen before, but this, what's different about this is that these are focused on age. 51 years old, 11 years old, 9 years old, 27 years old, 36. You see, it's very different. It's not very uniform. And that was south of Kendall. 49 years old, 56 years old, 35 years old. A lot of old communities. If we head west, okay, we head west. Big city, right? Notice the roads are different. All right. 24 years old. Now we're looking at younger properties. Younger properties. Okay, and you can tell based on the geography. Okay, now we're doing some feature engineering now. Okay, we're going to be doing some feature engineering here. So feature engineering, meaning we're going to be now breaking our data down into information so that we can perform machine learning analyses. Okay, so we're moving from the geospatial components into more machine learning, more prediction and interpretation. So looking at sale prices. That's the geometry. Pre-processing the data. We're scaling our data here from using the sklearn library. Do it. Yep. Okay, xscaled. Okay, this is the xscale. So what this has done is generating that information and is turning it into an array. And it's a very large array. Does it say how large? I think here it'll tell us. So it's a very large array, okay? This big one here. So it's a very large array of these rows and columns that is going to perform its analysis. As we continue to run down our list, more arrays. Now we're training the data set. So after we built our arrays, we are now training the data set, and we tell it to split the data. So it takes the data set and it'll split part of it for training and the other part for testing. So that's what takes place at this one. It's very quick. And as you can see, the training data set is in this size, this many rows, 10,449 rows. And the test data set is 3,483 rows. And it's typical in machine language, you always utilize a large chunk of data for training and a smaller component to test. Now, I can tell you that in some circumstances, I've seen half of the data set being used for training and another part for testing, and then it will do its predictions. So it depends on the type of data and the amount of the type of data, and that type of data illustrates the amount that you would use. But the typical distribution that I've seen is 80-20 split. Next one. Okay, here we go. This here is utilizing the Keras model. So the Keras model, the Keras library, the Keras libraries is really important here. It pulls that information up and starts to run. And I show, was there a warning? Yeah, we got some problems. I think there's some problems there. Let's see what happens. Okay, there were just warnings. I'll have to go back in here and take a look, but it's only warnings. So there's some questions with it, but in our summary, we do have our neural network here. Okay, total number of parameters is 21,801. Total trainable parameters. Okay, so it's able to take all of them. It's able to take the data set and it's able to train them. Next. Okay, compiled. It's been optimized using a mean squared. Epics list. Oh, here we go. It's doing its thing. Just bring this down. Good. Next. Let's plot. Okay, training loss, validation loss. Okay, good. Keep going. Next set. The linear regression predictions. Excuse me, the linear regression predictions. Very good. Very good. So this is the model prediction, and this is the true value predictions. Okay, so looking at the test data now. Okay, and it predicted based on the test data. And you see that line going through there almost halfway? That's really good. That's a high, that's a good degree of correlation. That's what you want to see. Next. Okay, it's transforming data. Next. And a plot. Okay, there's a little bias in this one, is it? It's and because this is at a 5 instead of 3, it's going to have that plot indifference angle. So if this was 3 and this was 3, it would look more 90 degrees. I mean, 45 degrees. So we could change this to 3. Let's replot that. Much better. This tells us the length of the test file, which is what we saw all the way up here when we first trained our data. See, that's where that comes from. That's so important. And it's important to print so you see what your data looks like as you go along. And that's what a lot of this is. So it's a test to see where things are. Okay, value 14. Okay, sklearn metrics. In this case here, we're running sklearn on the files. Ooh, this would be interesting. Holy smokes, this is very good. What this says is that our R square is 0.99. It's almost 1. It's excellent, meaning that all the added features were useful for the analysis of the algorithm. Very, very, very good. So the predictions are good. All right, well, any questions you put in the chat, I will respond to those so we can take the conversation to another step. I thank everyone for participating today. It took us a long time, but do not hesitate to ask questions, and I will respond to them, and hopefully we can have another sets of exercises that go into more detail and respond to them. Thank you so much.